guys, welcome back. Mr. Watlington, and we're still talking subnet masking. Right now we're going to go into a fun subject that everybody always loves. Everybody. Variable length subnet masking, VLSM. And like I said, this is all part of CIS 225 network routing and protocols, okay? So if you remember our analogy from our previous subnet masking refresh, we went through this analogy with bingo, right? The bingo hall. Well, we're going to still build off that, okay? If you remember, we had a room where we could have 256 chairs, and we had a caller, the guy who calls the bingo, and the individual who goes and checks the cards and people win. So then we talked about, well, what if we wanted to have more games going at the same time, right? So we talked about subnetting, how now you could take that one room, you still only have 256 chairs, but we could divide it up and into 4 different rooms just by doing some partitions, and have 4 rooms with 64 chairs each. However, you would only have 62 assignable because of that caller and the checker. And that was all well and good, right? But you see what it is. If you notice, all of these were symmetrical, meaning that it was evenly divided. Let's say you have a situation where, okay, you want to expand your bingo business, things going well, but you notice that, well, you have a lot more people who want to play the $25 cards than you do people who want to play the $100 cards, the $500 cards, and the $1,000 cards. So you see, if you divide your room up equally, you're wasting space, because the one room where everybody wants to play, you can't get enough people in there, and then the other rooms, the $1,000 cards, you only got a handful of people in there, but you got this whole big room of 64, right? So now you see that you've been wasting, you would have a waste of space and not good utilization of space. So now this is where variable length subnetting comes in. So now what we want to do, let's say I want to divide the same room, we still got the same number of chairs, nothing changes with that. Well, I want to have one big room, because this is where all the low spenders, the people with the $50 cards. So I need 128 chairs in there. Still got to have that caller, still got to have that checker, right? So I'm good there. So, but now I don't want to have another one whole big room. I want to subdivide this room up into different sizes. So I can have my $100 card players here in a room with 64 chairs, right? Now the $500 card players, it's going to be a lot less of them. So let's say if I want to have 32 chairs in that room. And now the high rollers, these are the high roller bingo guys who want to play like $1,000 cards, $1,000 a game. Not a lot of those. So I only want to have about 4 chairs in that room. Now you got to remember, with each one of these, you got that caller, you got the checker, and so now you're going to have 126 available chair hosts here, 62, 30, and 4. And also, what you're going to see now, you're going to also have some extra space that's not being used for future expansion, which is good. Now, if you want to expand, because we haven't issued out all 256 of the available chairs yet. So, excuse me. So if you do the math, 128 and 64 and 32 and 4 comes up to less than 256. So that is what VLSM does for you. It gives you the ability now to break your network up into non-symmetrical sizes, like we were doing before, where everything was 128, 128, 64, 64, 64, 64, or 32, 32, 32, 32. Everything was symmetrical. Now we can have an asymmetrical view or asymmetrical pattern of setting up our subnets. So let's take a look at this. So let's say we'll use this same analogy, right? Where let's say we need 128 hosts, we needed 64 hosts, 32, and on down. So let's take a look at that. So this would be our subnets. So let's say we're going to need 4 subnets, right? With an available number of hosts of 126, because we've got to pull those 2 out. It was 128, but those 2 chairs got to come out. 62, same thing, 30, and 2. How do we do that subnetting? That's what VLSM helps us do. Well, yes, we start back with this handy dandy chart that we always refer back to. If you remember that from our earlier video, where we have the mask, and that doesn't change. The number of bits associated with each mask, the number of hosts. Like I say, this is the -2. We've already done the subtraction. 126, 60, 30, 14, 6, 2 on down. How many subnets and how many increments. So everything is the same. So let's do the subnetting. All right, we're going to use an IP address of 192.168.10.0 and a CIDR / of 24. That tells us that is going to be 255.255.255.0. 8 plus 8 plus 8 is 24. All right, so using that, now if my first subnet, right, I need 126 hosts. I need to be able to have 126 available IP addresses. So to do that, I have to use this mask of 128. That's the only place I won't be able to get that many hosts, right? None of these others will allow that. So I will use that host, and that tells me that the number of bits is going to be required to be /25 with 2 subnets, okay? So my first subnet is going to start with 192.168.10.0, and my first host is going to be 1. The last host is going to be 126, broadcast 127. No different than we had done previously with subnetting. This is going to be a CIDR of 25 because I needed 126, and that's what it gave me. And now my subnet is going to be, my ID, I'm sorry, is going to be 192.168.10.0/25. And that's going to be my subnet 1. I look at subnet 2, I'm going to need 64 hosts for subnet 2, or 62 assignable. So now I'm going to start with what I have left over. So my second subnet is going to start with 192.168.10, and I start at 128. Why? Because I've already used the first 128 out of the 256. So that first set of chairs, 128 of them have already been assigned to that big room. So now I start at 128, and I will assign based on the increment. The increment is what? 64. So now I'm going to increment by 64 for my second subnet. So now I'd start at 128. The first assignable is going to be 129. 62 hosts from that is going to give me 190. The broadcast is going to be 192. So that is my second. That's how I get those 62 available IP addresses for this second subnet. CIDR is going to be what? 26 instead of the 25. Now I've basically cut that in half by 20 to 26. That gives me the number of hosts I needed, and my address is 192.168.10.128 because that's where it starts at with 26. So that tells me that my first assignable IP address is going to be 129. Because this is where my IP address range starts, and I'm incrementing by 64. So that gives me my first 2 hosts. Let's see how we get that third. Same thing, start at 192, but I have to start from where now? Remember my broadcast from my last subnet was 192, 191. So now I have to start at 192. So now 192.168.10.192, first assignable is going to be 193. The last assignable is going to be 222. Why? Because I needed how many? 30. To get 30, I use a mask of 224, and I'm incrementing by 32. That gives me 30 hosts. So now I'm just only going to be using 30. So I go from, 192 to 223, and that gives me 30 assignable hosts. 32 altogether, 30 assignable from 193 to 222. The CIDR for that is going to be 27. That's where it comes from, 27. And the number of hosts needed, 30, and I got those. And the ID for this is going to be 192.168.10.192, right? Well, how do I get 27? Okay. Now let's get the fourth. Now for the fourth one, I only need 2. I only need 2 assignable hosts. Well, how can I get 2 assignable? Well, if I come over here, right, look, boom, I find that gives me 2. So if I use the subnet mask of .252, that gives me 2 assignable hosts, and it's going to increment by 4. So now I start where I left off before at 223 was the last IP address in this third range. So on my 4th subnet, it starts at 224. So the ID is going to be 192.168.10.224, and it increments by 4. So I got 24 to 27. Those are the 4 IP addresses. However, there's only 2 that are assignable, 25 and 26. Even though I got 4, that's the ID can't use it. That is the broadcast can't use it. So now you see that gave me my 2 IP addresses. The CIDR is what? 30. Yep, 30. Gives me the number of hosts I need. And if I look at the ID, 192.168.10.224 with CIDR of 30. So this is how I get my 4 subnets using VLSM. 126, 64, 32, and 2. Nothing tricky there, guys. Nothing tricky at all. And then also, because I still did not use all 256, now I still have room for expansion if I want to later. Because if you notice, I stopped at 227. So now I can start at 192.168.10.228, 228, and I can assign from 228 all the way up to 255 for another subnet if I want to expand later on. So that is how VLSM works. Okay, now let's use an example from the class, right? Our class project. If you go to phase 2 of the class project, you see we built this network out a little bit bigger. So now if you're doing VLSM and you're looking at a network like this network, the first things you have to be able to do is identify your subnets. Okay? So before you can start doing subnet masking on a real actual network, you have to identify each subnet. So let's identify the subnets, okay? And the way you're going to identify subnets is off of the routers. So off this router, I got PC1. That is a subnet. Okay, if you remember routers, they connect disparate LANs together. So this is a subnet. Also off this router, I have PC2. That is another subnet. What else we got? We got a router down here, right? Off of, excuse me, router 2, R2, we have a subnet. And this subnet, it has, off of this switch, it has a PC as well as it has a server. Okay, I've identified the subnets, right? Hey, somebody caught that. Yes, because this is many times where a lot of us go astray, is that there is still one more subnet to be identified here. Where is it? If you say it right there, you are correct. Yes, because you see where these 2 switches connect together? I mean, I'm sorry, 2 routers connect? Well, that is a subnet also that's going to require IP addresses, right? Because each of these interfaces, every interface on this switch, whether it's an Ethernet interface, whether it's a serial interface, each one is going to require an IP address. So the interface between router 1 to router 2 is also a subnet, which is going to require 2 IP addresses. Okay, so now if we look, we've got, excuse me, 4 subnets. The next thing you want to do is identify how many hosts you're going to need per subnet. Now, in our project, in our class, in this PC1, in this subnet, we're going to need 75 hosts. In the PC2 subnet, we're going to need 50 hosts. In the PC3 subnet over here, we are going to need 25 hosts. And from router 1 to router 2, we're going to need 2 hosts, 2 IP addresses. These are, when I say hosts, think of these as IP addresses. You're going to need 75 IP addresses here. I'm going to need 50 IP addresses here. I will need, excuse me, 25 IP addresses here and 2 IP addresses there. So now that I've identified those, now we can actually kind of go into how do we subnet to make this happen? How do we do the subnetting? Okay, so here again, go to our chart. And really it's the same process we did before. We're going to use basically the same IP address, and we'll start walking through each one. So for the first subnet, I got 75. I need 75 IP addresses. To get 75 IP addresses, I can't get it from here. That's only 60. That'll give me 62. So I have to go here to get 75. Got it? 128. So with the subnet mask of 128, that's going to be 25 bits, meaning I'm using 225, 225, 225, which is 8 bits each, or 24. And then I'm going to use the first bit out of the 4th octet. That's where I get 25 from. There's going to be, it gives me 2 subnets, and it's incrementing at 128. So with that said, so now I know what my network ID is going to be, 192.168.10.0, because that's where I'm starting from. So it's from 0. First assignable is going to be 1. The last assignable is what? 26. Broadcast is going to be 127. And that gives me the CIDR of 25. So I needed 75. I got 126. I'm good to go. And like I said, my network ID is going to be 192.168.10 with a CIDR of 25/25. That covers my PC1. If I look at PC2 subnetwork, I need 50 IP addresses. To get 50 IP addresses, where does it fall here? Right there. I gotta have to get 62, right? 62 to get 50 out of that. So now I do the same subnetting as we did as we've already done, but where do I start? Okay, the last one I use here, as you remember, is 127. So now I have to start at 128. So 192.168.10.128. The first one is going to be 129. The last one is going to be, because I'm incrementing at 64 now, right? So it's 129 plus the increment at 64, which means there are 62 usable. So that'll be from 129 to 190. Those are my 62 usable IP addresses. If I go from 128 to 191, that'll be 64. But the first one and the last one cannot be assigned. That gives me a range, the CIDR of what? 26/26. And it gives me a network ID of 192.168.10.128 CIDR 26. All right, going to my PC3. How many do I need? 25. You get 25 IP addresses. I've got to come where? Right there to the 30. That'll give me a range where I can get 25 assigned 25 IP addresses. Same thing. The only thing I can say to where do you start? Pretty simple. Just go to where your last subnet ended, 191. So now my first one is going to be 192.168.10.192. First assignable, yep, 193. The last assignable. Now, if I look over here, it tells me that I am incrementing at 32, right? I got 30 hosts, and it's incrementing 32. So I need 32 in this 32 address range. So from 193 to 223, I'm sorry, from 192 to 223 gives me that 32 range. Here are the 30 that's assignable from 193 to 222. My CIDR is going to be what? 27. How many did I need? I need 25. I've got 30. So I'm good. And there's my subnet, my network ID, 192.168.10.192 CIDR 27. Now for that router 1 to router 2, remember I only need 2 IP addresses to assign to the interfaces on router 1 and router 2. 202. So where can I go to get 2? Where can I go to get 2? You got it right there. .252. That's the mask I need. Okay, and it increments at 4. So meaning that there's going to a group of 4 IP addresses. All right. So where do I start on this one? Again, it's where I ended on the last one. Okay. So I ended at 223. So I start at 224. 192.168.10.224. My first assignable is going to be 225. The last assignable, 226. Broadcast, 227. Those are my 4 IP addresses. I can only use 2. First, last, unassignable. The CIDR, the number of bits, 30 bits. Okay. And like I say, the IP address. So class, like I said, I hope this helps you out. Now, but we're not finished here. There's something else that we want to talk about. Now, even though we have set up our ranges, right? The next thing we want to do is to be able to actually assign IP addresses in each range. All right, here's what I mean. So if you look at what we set up in our network, and we identified all the subnets. So now we need to assign the IP addresses in each of those ranges. So if you remember what we just finished, right? These are our 4 subnets, PC1, 2, 3, router 1, router 2, and we need 75 hosts. This was our subnet ID for subnet 1, PCI 1, subnet ID for PCI 2, 3, and 4, and the associated subnet mask. So in your project, what you want to do now is to actually start assigning IP addresses. So if I look at this first subnet, right, PC1, okay, if you remember, I can't use the subnet ID. So I have an interface on the router and I have my PC. So those are the 2 IP addresses I need to start with. So what I would do first is assign that first usable IP address to my interface on the router, which would be 192.168.10.1. Then from there, I would now start assigning the other 74 to all the PCs that's going to connect in this subnet. So like I say, PCI 1 would be 192.168.10.2. If I have another PC2, PC3, other devices, then I would incrementally give each one an IP address. Okay, do the same thing for this subnet, which is going to be your router, same router, but it's your other interface. It's going to be the second interface off of that gigabit interface off of this router. Okay, if I look at router at PC2, there's 50 hosts. My subnet ID is 192.168.10.128. I can't assign that. Again, I cannot assign that as a usable IP address. So I have to start with the next IP addresses, which is 129. So this interface will get the IP address of 192.168.10.129 with the subnet mask of 255.255.255.192. The piece, this actual computer, and it will get the next IP address, and I would continue to assign all, the rest of the 50 or the 49 with these IP addresses, and they would all then have the same subnet mask of 255.255.255.192. So that's how I would assign that. Now, looking at this third subnet, right, PC3. Okay, I need 25 IP addresses in there. The ID is 192.168.10.192. Okay, and the subnet mask is 255.255.255.224. So this connects to router 2. So now on router 2, on that interface, I would assign it the first assignable IP address of 192.168.10.193. Why? Because I cannot assign 192. That is the ID. And the subnet mask is going to be .224. So if you're working packet trace, or if you're working on Cisco and you've got to assign that address, this is what you would assign to that. And then every other device, like in this instance, the PC, I would assign it 194. The server, I'd give it 195. And the rest of these 23 IP addresses continue down that line: 195, 196, 197, 198, all the way up to you've assigned all 25. And then the last one would be that router, okay? The subnet between the two routers, And if you look at that, and here again, like I say, the subnet ID 192.168.10.224. Can't assign that, but I can assign the next one. So I give one router .225, give the other router .226. That one gets 225, I give that one 226, just because. And they would have the subnet mask of 225.225.252. Okay, so now you see we broke it up into subnets. Then once we broke it into subnets, then we start assigning the IP addresses based on the subnets. Remembering that you cannot assign the subnet ID. All right, class. So I hope that helped you out with understanding, or a little refresher on variable length subnet masking. And if you have questions, feel free to reach out. Again, this is Mr. Wallington. Thank you for your attention, and I will probably have some other videos coming out on some of these other topics later on. Take care.